Before we dive into today's episode, which was recorded a few weeks ago at FedSupernova 2025 here at Capital Factory, I have an exciting update. Crossbow Launch Systems, who you're about to hear about from co-founder Jason Hundley, just landed a new Pentagon contract to boost rocket motor production. The 4-year contract, worth $191 million, is an exciting development, and it makes for perfect timing for this episode. I hope you enjoy this conversation with Jason about his background and Crossbow Launch Systems' additive manufacturing breakthroughs.
What do you think was the different key maker for you to?
So I think it was where early investors were seeing one of our focus areas was where Northrop Grumman's business model and where Jet Rocketine's business model was not fitting some of those new requirements, specifically in the hypersonic arenas. Your technology is like literally sitting in a college lab, and it's like partially assembled in a building. These early stage investors, these seed round stage investors, they make bets and they go, well, shoot, you know what? You may not make it all the way, but you may make enough proof point where Northrop Grumman might become your purchaser, and maybe they add it into their arsenal. So they're making a risk hedged bet that you're not necessarily going to take over Northrop Grumman, but that you've got enough team experience and you're tackling a problem in a smart enough way that, even if you get halfway there, there could be off ramps, where they could also make a return on investment.
In other words, Jason's a badass.
Yeah.
Welcome to Austinpreneur, our show about the stories that made Austin, Texas a global hub for startups. The show is produced by Capital Factory and hosted by me, Nick Spiller. As a reminder, by joining Capital Factory, you can plug into the ecosystem where the stories on this show were set. Learn more about us at capitalfactory.com. All right, welcome back to the Austinpreneur podcast, where we discuss technology here in the heart of Texas. Today, we're here with a very special guest. We got Jason Hundley, CEO and founder of Crossbow Systems. Jason is an active duty Marine and a NASA researcher. He spent 2 decades as a subject matter expert in space exploration, defense tech. He's advised on lunar landers, space exploration architectures, commercial space ventures, etc. Built high-performing teams, companies like 0 Point Frontiers, Orion Propulsion, Miltech, and Northrop Grumman. Just learned he grew up in Dayton, Ohio, and going to the Air Force Museum. I'm excited to talk, Jason. Welcome to the show.
Hi, thanks. Yeah, a long time ago, I was supposed to be, growing up, I was going to be an Air Force fighter pilot. And about 12 years old, you get these and can't qualify.
So, is that still a rule, or?
I think they've got some, there is like 1 or 2 permissible like corrective surgeries. And I think if you're not at the fighter pilot level, you could get a lower pilot's license. But back then, this is the 80s.
Right.
So if you weren't going to jump in an F-15 or F-22, why would you go fly?
I've actually heard that story from a handful of technologists in the space. They were wanting to be an astronaut or pilot.
Oh, yeah. The aerospace and defense is littered with the space camp astronauts, the Air Force, fighter pilots. It's like, if you can't be on one side, be on the other.
Yeah, absolutely. Absolutely. Well, we're here to talk about solid rocket motors. Your company, Crossbow's, leading the next generation of them, and in my opinion, I think a lot of people's opinion. But why are solid rocket motors still relevant? You hear a lot of discussion about liquid reusable systems, but what's the place for SRMs?
So, so in rocket propulsion, unless, let's say, you drive a car and it's not electric, internal combustion engine, you put in gasoline, air comes in through the front, that's called your oxidizer, it mixes together, that creates that propulsion. Same way with an aircraft, oxygen comes in through the atmosphere, mixes with the fuel, that creates combustion, and that's the thing. Rockets fly too fast. You can't pull the air in from the atmosphere. So that's called rocket propulsion. So now I need to take all my fuel and all my oxidizer with me. Now, if you're trying to go to outer space, throughout the solar system and everything, what you care about is gas mileage. I need to be as efficient as possible. And so we found liquid rocket propulsion has a very, very high gas mileage, or ISP, because we got to use special terminology in the rocket world. We can't just use gas mileage. So the best way to do that is through liquid fuel, and then a gas oxygen is pretty hard to gather around, so you chill it, and you chill it to a liquid form, and you make a liquid oxygen tank. And then you have a whole bunch of valves and plumbing, and then it goes into a chamber, and boom, there's your rocket thrust. But highly efficient to go to orbit, highly efficient to go to the moon, and the outer planets. So as opposed to that Prius, solid rocket motors, the oxygen and the fuel are baked into a solid form. So it's the best way I describe it is a heavily over-engineered firework. But what that makes it is sort of like your 4x4 ATV. It is super rugged. You can carry it around with you in the battlefield, withstand extreme temperatures. It makes extremely high G maneuvers. And so it's ubiquitous across defense platforms. It's also extremely safe because, I have this liquid oxygen tank, which has a bunch of smoke. You got to maintain these things. And I got a liquid fuel tank. When it's all just compressed into a solid form, you can make it in extremely different form factors. The most ubiquitous form of solid rocket motors that most people don't know about, but you kind of encounter them almost every day. If you jump into an Uber, jump into your car, the most ubiquitous form of a solid rocket motor is actually the little solid propellant charge for an airbag. Rapidly makes a gas and boom, there you go. So those are the type of applications that make solid rocket motors much more ubiquitous for defense, like the back end of missiles, everything you see going off in Ukraine, Middle East, Iron Dome powering, those are all powered by solid rocket motors.
So we've had these. Like, what's the next generation of solid rocket motors? What do we need to invest in?
Yeah. So when we started looking at this problem, this is 2018, 2019. We were actually going to commercialize an orbital launch vehicle based on solid rocket motor technology. What we found was the vendor was Aerojet Rocketdyne, and to close the business case on that launch vehicle, the propulsion systems we needed to get down below a certain price threshold. And what we found was, due to the massive overheads of their factory, which has a huge amount of CapEx and OpEx to build these systems. The best way I can describe it, the standard technology today is, do you have a KitchenAid mixer at your house?
I have a few different blenders.
Yeah. So take a KitchenAid mixer and you make it explosion proof and make it like 2 to 3 stories tall.
Okay.
That's how we make the stuff. It was technology that got put in around, the Korean War in the 50s and the 60s. And the innovation that we had over time was, okay, well, if I needed more capacity, what I'm going to do is I'm just going to buy a bigger KitchenAid mixer. So I'm going to make a 1,000-gallon KitchenAid mixer, which is now like 4 stories tall. And it's explosion proof again. But now I've got to build giant facilities around these things, because if something goes wrong, and you don't build a very, very thick concrete walls and everything else, you could take out a city block. And so now all of a sudden you have this cycle where I need a lot more land. I need very, very large buildings. And if I am not maximizing the throughput on these billion-dollar facilities, it could cost a lot more to manufacture stuff. And so it becomes this giant CapEx exercise for companies to go, well, shoot, if I'm going to invest in this new factory, I need to figure out the most I'm ever going to build in the next 30 years. And then I'll make this billion-dollar investment. So our big innovation was, okay, one, I don't have $1 billion. So scratch that off the list. The second, in the way that the manufacturing is going today, there's new materials, there's new processes. there's things that don't lend itself to being thrown into a giant 10,000 pound mixing bowl. And so our thought process was we can invent a new method that would be A, safer, potentially not mixing 10,000 pounds at once, so doesn't need a big building. 2, better performing, because maybe we could take advantage of some new chemistries that previously you can use. And then 3, cost less, which is like the trifecta for technology. And so we started with a DARPA grant, but we invented this new process. We call it very, very creatively additive manufacturing of solid propellant. And so it's a new process that we invented at Crossbow specifically to tackle mainly the cost portion of what it takes to build things at scale for solid rocket motors.
And is it you're not using the mixture anymore, or what does your system look like compared to what you described originally?
So our system, the best way I can describe it, in fact, Josh, he used a good thing. He's like, oh, I understand this system now. This is like the tankless water heater versus, the water heater.
This is Josh's superpower.
Yeah. So I was like, that's a perfect analogy, right? You still need the water, but our system is continuously flowing.
Got it. You don't have a big
and
tank,
so, right.
1,000
So you reduce that big vat. We still have to take all the chemicals and we have to mix them, but we do it in very, very small, discrete stages. And so we have 2 or 3 stations where the various solids, loaded oxidizers, binders, and fuels are coming in. We control everything through a bunch of in situ monitoring systems. So we've got a whole bunch of sensors that we monitor how it flows, but never, even for us to create like 4,000 pound rocket motors, there's never more than 200 or 300 pounds in the system at any one point in time. And then the end, it looks like, you got a giant standing robotic arm. And so it kind of comes out, it kind of really looks like unappetizing, like gray soft serve ice cream is the best way that I could say how it kind of comes out. For our inert products, when we do simulant, we dye it blue. And so you'll see blue articles out on our booth that we have here at the FedSupernova. So if you see our stuff in blue, that is inert. We don't use the fuel that it's normally ammonium perchlorate. We use ammonium sulfate.
Got it. And you mentioned we are here at FedSupernova, and we kicked off with the tour to the Crossbow facility here in Texas. Tell us, so what have you built, I guess, half hour, 45 minutes south of us?
Yeah, so literally, I will call it opposite of normal traffic flow, which is pretty intense in Austin. But yeah, between Lockhart and Luling, Texas, is our first production level campus. It's an expansion from our R&D facilities that we operate and maintain in New Mexico, in Socorro, New Mexico. But basically, it's our first production scale thesis in the solid rocket motor industrial base. So we'll have eventually like 3 production lines. So 3 energetic producing systems. Then all the rest of the associated stuff of testing and, propellant labs and NDT, non-destructive type of testing, static fire testing, integration buildings to manufacture full up solid rocket motors. And so we're in the process of finishing up our phase 1 construction. Our phase 1 operations will start hopefully in the next couple months. And that will allow us, from a sort of level up or an unlock feature, whatever game levels, that'll unlock our first 1 million pounds of capacity.
Okay.
Which,
how can we think of 1 million pounds of capacity? What's comparable to that?
A pretty good standard for, we'll call it small tactical missiles that are in air defense in the Ukraine or, being in Israel. Typically, those are powered by solid rocket motors that are like 50 to 100 pounds of energetics production. We use that pounds because you have to deal with a whole bunch of safety regulations. You're dealing with massive amounts of chemicals and materials. And so the way that the world views our production campus is in terms of pounds of capacity, not necessarily number of rocket motors.
Yeah, got
So
it.
roughly, 1,000,000 pounds is about 10,000 solid rocket motors per year.
It's good number of motors.
Yes, yes.
And the output is the fuel, or is it the whole rocket engine?
In the campus,
Yeah,
it's the entire product.
yeah.
So that way, that product will go and either get shipped to what we call like a Lockheed Martin, who's a strategic investor in Crossbow, or to say Boeing, who's another strategic investor in Crossbow. Like they typically will buy the propulsion from Aerojet Rocketdyne, now owned by all three, or like ATK, that's owned by Northrop Grumman. And so we are working on different programs where we're doing drop-in replacement type of motors for both strategic and tactical systems.
And so you mentioned strategic partners with Boeing and Lockheed. And what's the purpose of that? With we're here at a conference with a bunch of entrepreneurs trying to figure out how to break in, partner with the primes. I mean, what's the advantage other than maybe the obvious piece? And if you have any maybe tips of developing those types of relationships.
Sure. I mean, right, wrong, or indifferent. A lot of what's called program of records or legacy systems, a lot of them are developed and procured via the prime contractors that own the systems.
Yep.
Lockheed Martin just happens to be the largest purchaser of solid rocket motors in almost Western civilization, because they have about 10 or 11 different program of record missile systems that are used throughout NATO and DoD and Israel and other places. So for us, since we want to manufacture SRMs, but other than buying them ourselves for our launch vehicles, it seemed natural to work with partners like Lockheed and Boeing and offer them a lower cost alternate supply channel, because a lot of our missile systems have been heavily constrained by their throughput capacity. And one of the critical throughput capacity limiters has been the available capacity of the propulsion.
Yeah. So what breakthroughs in materials, manufacturing, design are really you're most excited about? We've touched on a few different ones. Are there any other pieces of the puzzle that we haven't touched on?
Oh yeah. So we've been focusing on one major feature of the technology: scale.
Yeah.
So we have what we call backburnered tons of features over the last several years in pursuit of making sure that the system can scale. Scale for us means diameter ubiquitous. So our production system can do anything from 2-inch to 60-inch diameter solid rocket motors. Anything that can be up to 6 or 7 feet high. And so what we made sure is we've held that feature as paramount, because right now what we hear from folks like Lockheed and Raytheon is, I need throughput, I need capacity, I need that level of capability. Since we happen to have machine vision watching everything we do, since we have 80 sensors up and down the system, it's computer controlled, it's fairly automated, it has a fantastic feature called pause. Like when you are doing things in a total mixed batch, if something goes wrong, there is no pause. What you have is something that is already time triggered to cure. And so if something goes wrong, and I have stuff in a 400-gallon bowl or a 1,000-gallon bowl, that's going away. That's just called scrap at that point. With a pause feature, which we've used tons because we're entrepreneurs, we've learned through mistakes and everything, we can just pause our system. And really, we only have about 10 pounds of material that's curing. just deposit that off of the side, go check what went wrong. And that gives us a huge instantaneous quality feedback cycle.
Yeah, huge risk mitigation too at scale.
Well, and less waste.
Yeah.
And so you're more efficient, you got less waste, you can debug things, and then just, and restart the system very quickly.
So your whole system is highly driven by AI?
Not yet.
Not yet.
That is the next feature. We're super excited.
Yeah. So draw the lines there between your automation and then where it really becomes an AI-driven production system.
So as we've been developing at our R&D facility, we printed out hundreds of motors, and now we gain all this data. Yeah. So we got visual data on the system. We've got not only, we've got sensor data on the system. We've got data on the chemicals themselves throughout the process. And then we get what's called afterwards, we do a whole bunch of testing. So we get burn rates, we get mechanical properties. But now we have a complete and utter digital record of the entire system. Not just the end product, but while it's being manufactured. Yeah. So if you imagine now, what we can create is a complete digital twin of the product as it's being deposited. If you have that capability because you've got all this data, the natural progression is, now I can take an AI agent on top of that. And now I can start doing things like optimize. Yep. I can optimize a specific point in space, going, I want a higher burn rate here, I want a lower burn rate here. I want this exotic chemistry here. And now you can start doing things like tuning your grain chemistries, which again, not really available when you're using the old sort of big single batch cast and pour technology. Yeah. So there's huge unlocking features that we're excited about.
So you have the data. Next step is to develop the digital version that you can apply the AI agents to, and then very interesting, very interesting. And so if we get it right and we really nail the production of these motors, what does the world look like? And what's your vision for the space?
So, the
world, or maybe off-world.
So from our take, and one of the things that really excites me is, especially with manufacturing technology that, isn't, like I said, it's not a $50 million CapEx exercise to go get a single piece of equipment. That allows us to continually look around other industries, pharmaceutical industries, the robotic industries. But now we have a manufacturing system that is completely upgradable, completely swappable for new parts when we see better technologies come in. And so it can continually evolve and unlock new features in the chemistries, unlock new features in material science, unlock new features in different markets where maybe you never thought about using an energetics application because guess what? It wasn't a good form, fit, function for it. But now all of a sudden it's like, hey, you know what? Maybe I've got a self-repairing tire because I can, put a gas charge of an automatic solid in it to go just reboost it. You don't have to fix a flat tire anymore. Yeah. There's other applications like in aircraft safety systems. Pretty much every aircraft safety system is a big boost of a charge. Maybe you can design them to be more ubiquitous and safer. Cheaper airbags in ground vehicles. So there's, I think, some interesting unlockable applications that as we...
Dual use applications, as we say in our community.
Oh, yeah. Austin is always about dual use.
That's right. I've learned. Excellent. Well, anyone in the audience, if you have a question, Mr. Virginia Tech over there, I'm looking at you. But in a second, you can think of it. That was the priming. But let's talk about fundraising a little bit. That's a big topic on our show. You've hit your website. I see you've raised $105 million.
I wish it was $105 billion.
I feel like that's the next round. That's the next round.
Capital Factory, step up.
That's right. Well, I keep getting the zeros mixed up. The rounds keep getting bigger. $105 million Series B. And what's the core lesson you've learned on the fundraising trail as a CEO?
Okay. Well, so as an entrepreneur, this is a lesson. Anybody that starts a business, I will tell you this right now. Officially, we closed our fundraising cycle. We did a press announcement, everything else. We're always raising money. I have yet to be able to cut my hair yet because we're still almost in unofficial fundraising mode as a continual cycle. And so that is the single largest lesson that I've learned is like, oh yeah, we close this round, but now all of a sudden it's like, oh, well, hey, you know what? We got more mature as a company, so now we may be able to take certain of our CapEx equipment and take certain pieces of our infrastructure, maybe turn that into project financing. Then all of a sudden it's like, you'll notice that your new investors, all of a sudden it's like our chief revenue officer, and Maureen, when we were co-founders, like as soon as you close a round, you get 10 phone calls that people are like, what? You were raising money? You didn't call me? I didn't know. Can I still get in? Can you still do this? So those conversations are still going.
Yep. The momentum.
Yeah. So trying to look right now at our next sort of strategy of what we're going to do with some capital, looking at the programs we got in there. And so find also, as soon as you tell your employees you've closed a big round of capital, the innovation and ideas that come up from within the company of what they want to do with that capital often exceed what you've raised as well. Yeah. So there's also an inward expectation of, wait a minute, we just raised $100 million. I've got a new project. It only takes 95 of it.
Right. Yeah, it's a lot of people are familiar with the phrase always be closing. There's a subcategory of that is always be raising. I've learned, especially in deep tech. I believe as an investor, the biggest risk of all these companies is just not raising the money you need to succeed. And it's, I think we're very fortunate and super excited to see rounds like your $100 million Series B. We did a handful of these that we've talked about on the podcast, and would have never really expected it 5 years ago, but we're rocking and rolling. Honestly, when we started making these investments in deep tech, that was what I was saying in our investment meetings was like, who's going to fund these companies down the road? If we give them all 10, 20, give them all, honestly, $100 million, like that doesn't get you there. But it seems like investors in the U.S. are really stepping up to fund this in a big way, private investors in a pretty big way.
Yeah, I think if anything that has shown us on a world stage, especially with the current conflicts, is that what we have been doing is no longer sufficient to even like combat what we're doing today. And so I will say probably one of the biggest things of the United States is, it's not just, government driven. It's not just research driven. There is a completely separate avenue where technology, where ideas can get brought into the market, into the stage. And I think what is, the last several years has taught us is like, hey, the defense market is a market that needs that level of innovation because, right, wrong, or indifferent, the government can be very, very constrained on how it allocates its funds and resources.
Yeah. It's government, like customers, I think, don't exactly know what they need.
Right.
And what you see a lot of these companies doing is the classic tech approach of listening, understanding the problem, but making, sometimes genius inferences to build what they really need, getting the money to fund it before the government even recognizes it, puts the platform in front of them, and then you're seeing the government buy it and really building what they need without getting a whole list of requirements and this whole thing that's drawn out by the government partners you're working with.
Yeah, at Crossbow, like we have investors and they're like, my gosh, you guys must be geniuses to figure out that the world, would need this and do this, ahead of time, 4 or 5 years from now. And of course, our immediate answer is, well, of course we're geniuses.
Right.
It's like, it's not like world events conspired. It's like, yep. We had the crystal balls sitting right here. We're like, whew, we need to have that campus online. So sometimes there's circumstance meets, opportunity and tech. And sometimes when you hit that, we'll call it that little apex there of that, you kind of find that, fundraising and capital starts becoming a lot clearer and a lot easier.
I think the other big factor in it, both for the founders and the investors, is courage to go out and do it. And it's not easy, any of these things. And we all can get, smart jobs at bigger companies that often probably pay just as good. But yeah, it's actually the courage to go out and do it.
Yeah. And I will just say, any entrepreneur that literally goes out there with the idea, it's like first off, grow an extremely thick skin. Okay, unless you've come from the exact right school and everything else, it's like you will hear no.
Right.
No will be part of what you hear. And
just wake up and ask them to punch you in the face a couple times, and then you're ready for the day.
And you may hear no from people, but it just may be, it may be no, never again. Never assume that. Like there's been plenty of people that like we were talking to in 2018, 2019. Absolutely not. No. Yeah. They're on our cap table now. It's like, sometimes it's just the right fit at the right time. Sometimes they're in their fundraising cycle, because what I've also learned is the fundraising hamster wheel for the venture folks is just like for the companies. They're raising a new fund every 2 years, to invest into the next innovation.
Right.
So,
yeah, and it's on that, I think the companies have far more differentiated pitches, and the investors are kind of out there all pitching the same thing, a little different, a little network, and I think at Capital Factory we've done a lot to be different too. But it's like on both sides of it, we gotta come up with the capital.
Yeah, but get used to no.
Right.
Get used to
enjoy
not ever taking it personally.
Feed off the nose, and it only takes one yes in a lot of cases to really put you in business. So, seen it time and time again. Does anyone have a question for Jason?
I have a question. So you mentioned like additive manufacturing, solid propellant. So you said it solves the cost issue of making these propellants. So does that mean you can manufacture them at a cheaper cost than ATK and Aerojet Rocketdyne?
So it solves part of the cost issue. Mainly for certain products, to be quite honest, I would not recommend our technology. Like ATK makes this thing called the SLS booster, and it's got millions of pounds of energetic for one booster. I would probably say our technology is not a good fit for that product. Where we've looked at in our cost models when we're estimating not just our AMSP technology, but also some innovations we're bringing to the rocket motor itself, depending on the size, we're estimating anywhere on the small scale size to be like in the 10 to 20% savings, and in the mid-scale size to be in the 20 to 40 to 50% range in savings. And so it does really matter about like the specific size and sort of the use applications, but that's roughly what we're seeing now.
Good question. And a follow-up on that. So what led investors to invest in your company when there are already companies out there like ATK that are just like manufacturing all the way from normal high like missiles to SLS boosters? So what do you think was the different key maker for you to get?
So I think it was where early investors were seeing one of our focus areas was where Northrop Grumman's business model and where Aerojet Rocketdyne's business model was not fitting some of those new requirements, specifically in the hypersonic arenas, which was a new class of motors that hadn't really been developed for a while. And so as we started our initial fundraising, we did auger in like one specific application as a thesis point for the technology. And then when you talk to the investors, especially even in the early cycle, it's like, hey, okay, your technology is like literally it's sitting in a college lab, and it's like partially assembled in a building. these early stage investors, these seed round stage investors, they make bets and they go, well, shoot, you know what? You may not make it all the way, but you may make enough proof point where Northrop Grumman might become your purchaser, and maybe they add it into their arsenal. So they're making a risk hedged bet that you're not necessarily going to take over Northrop Grumman, but that you've got enough team experience and you're tackling a problem in a smart enough way that, even if you get halfway there, there could be off ramps, where they could also make a return on investment.
In other words, Jason's a badass.
Yeah. Yeah.
Any other questions from the audience?
What'd you do in the Marines? And is there anything that you learned in the Marines that carried over into you wanting to be an entrepreneur, or how you attack problems?
Oof. Okay. So I spent 4 years active duty Marine Corps. It was my MOS. I got detailed to be a mechanic because I went in just open contract. They taught me rifle skills extremely well. So I got detailed and tasked as a Italian rifle range instructor. So did a lot of that kind of stuff. Mainly fixed a whole bunch of broken equipment for about 4 years. In the Marines, this is the one thing you learn. The Marines delegate down fairly well. The Air Force will, I will say, sort of the lowest level of fighter in the Air Force is an officer. They're the ones flying fighter jets. And so lieutenants are like privates. It's like I think I saw an officer like 3 times in the Marine Corps. Like, yeah. I was a fighter pilot in the Air Force, by the way. Yeah. So it's like, it's completely, opposite. So it's like, you've got like, I was an NCO in the Marine Corps. I had like 20 people I was responsible for. It was like, putting in charge $100,000, worth of equipment. And the expectation is you're getting it done. And then also you learn that, I will just say, one of the tenets in the Marine Corps was, well, we'll always have something to drive as long as the Army's around. So the entrepreneurship of the beg, borrow, steal from we'll call it the better funded services. Sure. That was also a tenet in the Marine Corps to go get that job done.
It's scrappy.
Yeah. It is very much the scrappy of the services. But some things that I brought in, and have carried with me forever, is literally, the definition of team and teamwork. In the Marines, like, it is literally, when it is adverse conditions, it is face it head on. And I learned that difference, like, when I started, doing drills in the Army, when I was getting my officer thing. Like, in the Marine Corps, there is what we call react to an ambush. So in the Marines, the philosophy is if you get ambushed from, on a patrol, and people are shooting at you from one side or the other, Marines taught, turn directly to the ambush. You start rushing it and firing online all the way through the ambush. Then about 50 yards or 100 yards past, then you figure out, your what's happened and everything else. In the Army, completely opposite. And so my first drill when I was getting my Army, officer course, I'm in charge, and we got a bunch of cadets and everything, and we get into an ambush. Next thing I know, I'm finding I'm the only one charging the position, because everybody else has dropped for cover and is awaiting, either backup or everything else. And I've literally shot through the instructors, and I'm looking for all my teammates behind. But it is that entrepreneur spirit of, when something adverse is happening, you take it on head on. You don't worry, overthink sometimes, but basically, adverse conditions are going to happen all the time as an entrepreneur. It'll be personnel challenges. It's going to be team challenges. It'll be, adverse weather conditions. And you better be able to pivot, and you be able to be able to take it on head on. And if you can't do that as an organization or a company, then you kind of end up, locked into your own existence. And so there's plenty of examples of companies that have never been able to, build in that ethos of taking on adversity head on, that have gone by the wayside. Huge brand names that have just don't exist anymore because of the fact that they were not willing to innovate through their dilemmas or take advantage of things or pivot that business model. Yeah. And that's something that I've always brought forward.
Incredible.
So are you constrained at all in your ability to meet demand for materials and or technology today?
Possibly. I mean, currently we're not in high rate production, but our supply chain organization, we're constantly reviewing what we call we'll call it more fragile and single source suppliers. Okay. And because of the over consolidation over decades in this market area, there are single point supplier failures. And so that is something we pay attention to. And we are looking, and we've got a bunch of little research projects to see if there are ways around those supply chain bottlenecks. I'll tell you, one of the ones that is ubiquitous right now throughout the industry is like 4D carbon. So there's this material called carbon. They have densification of this carbon material. It makes it very, very great for the throat materials in our solid rocket motors. It's also great for leading edges on hypersonics. There is one manufacturer in the US, the 4D carbon. And so there's a couple that are up and coming. There's 2 or 3 companies trying to attack this, but that's like one example that we've always paid attention to, because it's like if you're not in their queue, you can all of a sudden your product is just slipped 6 months because you didn't get that critical material.
Great question. Well, Jason, thank you so much for coming on the Awesomepreneur podcast.
Oh, thank you, Nick. Really, really appreciate it.
Thanks for listening to this episode of Awesomepreneur. Don't forget to check out capitalfactory.com to learn more about us and join our community. If you have thoughts about the show or ideas on how we can work together, reach out to me directly via email, nickspiller@capitalfactory.com. Shout out to the Capital Factory Dream Team for making this podcast possible, and special thanks to Aaron Handworker, who masterfully recorded and edited the show. Come back next week for a whole new episode.